Vulnerable Wetlands and Stormwater Management Planning, Part 3, Headwater Streams and Vernal Pool Clusters. This is the third of 6 presentations in the Vulnerable Wetlands and Stormwater Management Planning series. In this segment, we review the concept of headwater streams and vernal pool clusters and discuss methods to create GIS graphic layers that will be used with the stormwater management planning tools. The map of headwater streams as percent of total stream length indicates that headwater streams make up the majority of river miles in the United States. EPA estimates that 53% of the total stream miles in the continental U.S. are headwater streams, and almost 60% of stream miles flow only seasonally or after storms. This map does not capture streams under 1 mile in length and shows only reaches that have no other inflowing streams at the 1 to 100,000 scale. When viewing the map, the darker the color, the greater the percent of stream length that is made up of headwater streams. This drinking water map is from the EPA Geographic Information Systems. The GIS analysis in areas for which data are available indicate that a large percent of the nation's population gets some of its drinking water directly or indirectly from intermittent, ephemeral, and headwater streams. Over 90% of the current population in Massachusetts receives drinking water from public drinking water systems that rely, at least in part, on headwater streams. Yet only half of these streams are in source protection areas or are safeguarded by the Wetlands Protection Act or the Federal Clean Water Act. For municipal planning, protection of headwater streams is critical to protecting the public supplies. EPA defines headwater streams as the uppermost streams in the river network furthest from the river's endpoint or confluence with another stream. They are the smallest parts of river and stream networks, typically first and second order streams. For this project, and for purposes of developing the GIS planning tools, headwater streams are upgradient of the first order streams depicted on the 1 to 25,000 scale USGS maps. These may include ephemeral streams that flow only in response to storm events and lack base flow, or small intermittent streams that are unmapped and upgradient of all bogs, swamps, wet meadows, and marshes, or otherwise fail to meet the Wetlands Protection Act regulatory definition of a stream in 310 CMR 10.04. These streams can be defined by topography or digital elevation landscape models and do not include stormwater conveyances. To develop the headwater streams data layer, we begin with the 1 to 25,000 scale USGS topographic map that illustrates the stream extents as identified and highlighted in the insert. A closer view of the insert shows the red squares as the farthest extent of the USGS streams and local contours. The heavy black lines represent the subwatershed boundaries or drainage divides that define the land area contributing drainage to the wetlands and streams. In this step, the MassDEP 1 to 25,000 scale hydrography data overlays the USGS topography. The topographic map data is muted without obscuring the contours, and simultaneously the stream network is highlighted to augment visibility and emphasize the branching structure for classification. The stream extent is unchanged by the overlay. The black lines are subwatershed boundaries defining the limits of drainage. The MassDEP wetland data layer was developed as part of an extensive and ongoing project of photo interpretation of aerial images to locate and outline wetland systems throughout the state. The data layer is available on the MassGIS website. The wetland data expands the furthest extent of streams and hydrologic connections beyond what is shown on the USGS topographic quadrangles. As such, it highlights headwater streams as we've defined them for this vulnerable wetland and GIS planning tool project. The streams that are upgradient of the USGS streams are highlighted in pink. They represent the 0, first, and second order streams that are considered headwaters. Overlapping stream reaches are subtracted and the resulting image is then visually inspected and manually edited to remove spurious lines that are clearly not streams, such as the highway drainage shown in the upper right corner of this image. A separate Headwater Streams graphic layer was developed in ArcMap that contains only the stream reaches and hydrologic connections beyond the extent of the USGS hydrography. Certified and potential vernal pools. Small wetland depressions such as vernal pools may be considered vulnerable wetlands. They provide critical habitat for breeding amphibians because they are topographically isolated from other surface water bodies, making them inaccessible to fish and other predatory aquatic organisms that depend on streams. Vernal pools and headwater streams are easily lost or degraded because of their size. They have a quick ecosystem response time and are sensitive to changes in hydrology and negative water quality impacts. The Natural Heritage and Endangered Species Program, also known as NHESP, has certified over 3,100 vernal pools and identified 30,000 potential vernal pools across the state. The potential vernal pools have not been extensively field validated, but their locations are relevant to town planners contemplating preservation actions and undertaking stormwater remediation. The certified vernal pools and potential vernal pools referenced as sensitive wetlands for this project are those mapped by the NHESP and are available to download from MassGIS. The importance of protecting undisturbed upland habitat adjacent to and between vernal pools is widely recognized in the scientific literature. Projects altering wetland resources can disrupt existing amphibian migration routes between vernal pools or between vernal pools and upland nesting areas. The wetland regulations limit protection for vernal pools to only that portion of the pool and the surrounding 100-foot habitat zone that actually fall within a resource area. Studies have documented, however, that areas beyond the 100-foot zone are biologically important for breeding amphibians and that preserving habitat connectivity between pools is vital to support viable populations. Habitat surrounding a vernal pool contributes to the maintenance of the vernal pool hydroperiod and the quality of the aquatic environment that ensures successful breeding. Avoiding new stormwater impacts to vernal pools, remediating existing stormwater impacts, and preserving undisturbed habitat around clusters of vernal pools will foster the continued viability of these ecosystems. Knowing the location of vernal pools and vernal pool clusters in the community can help to ensure that municipal land use planning efforts incorporate appropriate stormwater management designs consistent with the TMDL requirements that can best preserve, protect, and restore these essential ecosystems. The criteria used to define vernal pool clusters on these planning maps include 1. The presence of 2 or more vernal pools, certified or potential as mapped by NHESP. Good landscape connectivity between pools with few obstacles to amphibian migration such as buildings, roadways, etc., and a requirement that the pool be within 400 meters of each other to protect migratory and dispersal distances for juvenile and adult breeding amphibians. Once a possible cluster is identified, a GIS graphic can be created to locate the cluster in the landscape as shown in this image. Vernal pool clusters throughout the municipality can be identified and documented in a single ArcMap graphic layer for use in the stormwater planning tools. Lastly, vulnerable wetlands include critical areas as defined by the Massachusetts Wetland Stormwater Regulations. Critical areas are vulnerable wetlands because they merit special protection for pollutant reduction plans or added consideration when deciding where restoration efforts would be most beneficial. Critical areas are defined in the wetland regulations to include outstanding resource waters, special resource waters defined in 314 CMR 4, recharge areas for public water supplies, including Zone 1s, Zone 2s, and interim wellhead protection areas for groundwater sources, and Zone A's for surface water sources, bathing beaches, cold water fisheries, and shellfish growing areas. GIS data layers for all the critical areas defined under the Wetlands Protection Act and associated regulations can be downloaded from MassGIS. The next three segments of this presentation will address how graphic layers, critical area data, and other relevant information can be incorporated into the GIS maps to design stormwater management planning tools for your community. For additional information, please contact Nancy Lynn or Alice Smith at the MassDEP Wetlands Program. For additional information regarding vulnerable wetlands and using GIS maps for stormwater management planning, please contact Nancy Lynn or Alice Smith of the MassDEP Wetlands Program. Our email addresses are nancy.lynn@state.ma.us or alice.smith@state.ma.us. References and links for vulnerable wetlands presentations can be found on the MassDEP websites under Education and Outreach. Vulnerable Wetlands and Stormwater Management Planning presentation is funded in part by a Federal Clean Water Act Wetland Program Development Grant from the United States Environmental Protection Agency, Region 1.